All right, welcome back, everybody. Now, part 3. In part 1, we took Anchor and we built the Rust program end of our blog. In part 2, we crafted a little JavaScript application so we could deploy our blog to the Solana DevNet. In part 3, we're going to build the front end out of JavaScript with a JavaScript library to use to interact with that program. So let's get started. I have here the Anchor client. So essentially, we're going to build an Anchor client in JavaScript or TypeScript, and we're going to use this to set up our structure to interact with our program. I've already imported the Serum Anchor library into the file. And the next thing we're going to need to do is reference our IDL. So our IDL is our interface description language. And as you remember from part 2, we automated bringing our IDL into scope by just copying and pasting. There is a blog script. There is a copy and paste in the deploy script that will copy and paste it. But essentially, we want to pull this in. In SvelteKit, I can actually just import the JSON directly by referencing import IDL from Solblog. Actually, it's not Solblog. We've renamed it for blog tutorial for this tutorial. But in the repo, you'll see it's named Solblog. Doesn't really matter. We could name this whatever we wanted to, as long as it's the same name that matches that JSON file. And the other thing we'll need to do to build the Anchor program reference is to bring in the system program from Web3. Web3 is re-exported from the Anchor library, so we can grab that. Let's build a class to build out to be able to use our library. So let's go export defaults class. Let's call it Anchor client. Anchor client. And when we construct our constructor, when we construct our object, once I can spell it right. So what do we need in order to build the Anchor, to use the Anchor library? Well, if we go to the docs, you'll see here that to generate the program client for the IDL, we'll need to call Anchor program, the IDL, and the program ID. And if you dig into the examples, they have the same thing there. But you can actually go a bit deeper. And somewhere in the constructor, there is a third argument. There it is. Constructor is the IDL, the program ID, and an optional provider. The question mark here means it's optional. So we're actually going to use these 3 in our program. So I'll just copy and paste this so that you guys can follow along a little bit. So we need something that basically helps us do this. So we're going to need the program ID. We'll need, let's call it a config, where we can store whatever we want to store, and we'll throw in an optional key pair, and we'll default this to be empty. And let's make our constructor like this. So ultimately what we want is to use this anchor here, and at the end we want it to look like this, right? We want to be able to look more or less like this. So where the program is Anchor, program IDL, and the program ID. So the IDL here we have imported, so we're done that. The program ID, we need to import that from program ID. So let's actually assign the program ID for this object to be the one we just imported, which is great. So down here we can use either one, but we'll just be consistent and use this program ID. And we're also going to need some sort of provider. So I'm going to take advantage of this third argument, and we need to pass in a provider. Now we don't have this provider yet, so let's create it. In order to make an Anchor provider, go back to the docs, buried deep down in there somewhere, you can again just go new Anchor provider. There it is. And the options we need to throw in there are a connection. It's in this provider folder. So if we go back to provider, we can see that provider takes a connection, a wallet, and options, right? So new providers connection needs to look like this, right? So we're going to need a connection. So we don't have a connection yet, so let's save it to our option object as well. We can get a connection from Web3, which is re-exported by Anchor, like we already said, and that's just a new connection, the capital C. And let's grab the connection from our config HTTP URI, which is simply just going to be a reference to the devnet. It's going to be, api.devnet.solana.com or whatever that URI is. And same thing as we did in part 2, where we wanted to confirm, we're going to say the state is going to be confirmed there as well. And let's just keep the config as well. Config. So it's all part of our object. And there we go. We got a program ID, our config is there, our connection is set. Now, so we've got connection all done. What's the next thing we need? We need a wallet. Well, we don't have a wallet yet. So how are we going to build the wallet? We need a wallet. We'll worry about the options for now. The wallet. Okay, so wallet. So Anchor exports a wallet as well. As you can see there, it actually says, there it is. We were using this Anchor code as an example. So they say wallet is node wallet. Well, what's wallet? We go down to wallet. Export class node wallet implements wallet. And somewhere around here, it exports it as just straight up wallet. Here we go. And here you can see that Anchor exports node wallet as wallet. So we can go new Anchor wallet. And then we need to pass in a key pair to the wallet. So we have a couple of options here. We did give ourselves an option to pass in a key pair up here, but typically what we've been seeing in the Solana ecosystem is using a wallet to connect to our app so that the users can control their own key pairs. A very popular wallet to be using at the time of this recording is something called Phantom. So we'd love to pass in a Phantom key pair, but we don't have it yet. Oh, that didn't work out. I got a typo there. Try coding and speaking at the same time doesn't always work out well. If we go to the Phantom app site docs, go to the Phantom docs, and this will tell us how we can detect anything about Solana. So what Phantom does is it puts a Phantom object on the window object. So essentially, we can kind of reuse this to determine if Phantom is connected. So why don't we just shelve this for now? And let's try to say, if is connected and is Phantom. Let's put an optional parameter there just in case Phantom doesn't exist. It won't completely go nuts on us. Then we will use Phantom, and otherwise we will just put a ternary operator in here so we can kind of separate it out, or we could use the key pair that was passed in as a config key pair. We need to fill in this part. If it is Phantom, it's connected and it's Phantom. Let's say new wallet adapter Phantom. And so what we're going to do is pull in all the functions that Phantom passes to us and set that as our wallet. We don't have this yet, so let's make it. Let's make a file called, a folder called helpers, because it's going to help us navigate through the wallet. Let's call it wallet adapter, adapter Phantom. Now let's make it TypeScript. So here, what we're going to need to do is export class. Let's call it wallet. There we go. And constructor, we want to, when we construct this, essentially we want to make sure that it is connected. So if the window doesn't have Solana with is connected, then we want to throw a new error. Oops, why does it do that? New error. Connect to Phantom first. We'll set this public key to be window.solana.public key. Great. Now what we need is 3 of the, so let's go back to the Phantom docs. So we want to, sign a transaction, send a transaction. So there's signing a transaction here, signing multiples, signing a message. So we want signed transaction. So they call that signed transaction. So all we need to do is take this line here and make a wrapper around it. Transaction. The transaction is going to be a transaction type. Transaction, which we haven't quite assigned yet. I just want to throw this in there so I can copy that out. Asynchronous, so we're going to need to return a promise of a transaction. All we have to do is change that to TX for transaction short, and then return the signed transaction. Okay, so anytime we call signed transaction from our adapter, it'll in turn call window.solana.signed transaction from Phantom. Phantom will sign the transaction, send it back to us. We might as well set up the same sort of thing for signing multiple transactions. You can see how it says sign all transactions. So similarly, we can just kind of shortcut that in there, sign all transactions, sign all transactions. And we can also use this as a getter, so we can get the public key. So let's set that as a getter, get the public key from window.solana.public key. So that's a really simple, straightforward adapter to connect to Phantom. So once we create that wallet adapter object, we'll have that. So we need to import that into our code. So let's go import, import statement. We'll use from lib/helpers wallet adapter Phantom. And we'll call this, we named that export, right? Export, okay, so it's named. Keep it named. Nice. So now that we've got that, that will return us a wallet that's mapped to Phantom. Fantastic. This key pair is optional. So what we can do is check to see if there is a key pair. And if there is a key pair, we'll do wallet key pair. And if there isn't, what we'll do is we'll make a new one. Just copy this, and instead of passing in the key pair, we'll say anchor web3, which is the web3.js library. We'll use key pair, the capital K. and we'll generate the key pair for the user. So now we've got a wallet that we can pass into our provider and pass in the connection to whichever network is specified in our config file, which gives us a wallet provider. Pass that wallet provider into the Anchor program constructor, which gives us a program. And actually, we're going to make that this.program so that whenever we want to use the program, we just call it against our Anchor client object. In case the user wants to set the wallet later, we're going to add another helper function called setWallet. And we'll assume that the key pair is not passed in. And let's just paste a lot of the stuff back in to setWallet. And this will allow us to have a little bit of wallet flexibility with the key pairs if this Anchor client is created without being connected to Phantom, and then someone decides to connect to Phantom, or they want to swap up wallets, we can just call this setWallet, and this will essentially provide the same functions as before. Now, if you recall, in our Rust code here under source, we have initialize and make post. Initialize, make post. So we want to be able to call these. These are all mapped out through our interface description language, which is this JSON file over here, initialize and make post. So from our Anchor client, now that we've got a constructor to set up the Anchor program, we can set up our call functions for, let's do initialize first, initialize. And what do we need to do initialize? Again, if you go back to the Anchor, they have, await program RPC initialize. So we're going to kind of start with something like this. Inside of initialize, though, unlike that example, we've got a bit more complex code going on there. With calling the Anchor programs through the RPC, you need to pass in the accounts. Pass in the accounts, and you also need to pass in any signers. Right? So the accounts that we need are outlined in the IDL. The accounts are a blog account, authority account, and a system program account, right? So blog account, copying and pasting from the IDL. Blog account, ooh, why did it do that? It's weird. All right, blog account. So we're going to need a blog account. We're going to need the authority, and we're going to need system program as our accounts. Guess it's just going to format that no matter what. And the signer is going to have to be the blog account. So the blog account has to be a signer because Anchor needs to know that we have the keys to the blog account. Right now, there is no keys to the blog account because we haven't said what it is yet. So let's go blog, well, holy cow. Let's now create blog account then. So blog account is just a anchor.web3.keypair.generate. So we can generate any key pair for our blog account. As long as we have the key pair, we can create a blog account. Pass that in there as blog account. And actually, that's the whole key pair, but what we need is just the public key in our call. Right? If you go back to the IDL, you can see that it is a signer, which is why they're down here. But we just need to pass the public key in through blog account. So the authority is, whoever's paying and authorizing for the account. If you remember from our Rust code, the authority, the payer is the authority. So our payer is the wallet, And we have the wallet in our provider wallet. And again, we only need to pass in the public key, not the whole wallet. In Anchor, behind the scenes, under the hood, they're going to pass the wallet as a signer anyway, because it's built into the Anchor program. So we don't have to explicitly list our wallet under signers here. We don't have to, but we do have to list the public key as the authority. In the system program, we had identified up here, re-exported out of Anchor from Web3. So we take the system authority, put that down there, and we're going to use the program ID, which is the system program ID. Okay. Save that. That's better formatting. Thank you, sir. And then we can return whatever we want, but we can just return the blog account, really. Blog account, just so that we can grab the blog ID. So that's how we would do initialize. And then we also have our other function from the IDL is, so let's initialize, scroll down here, we've got make post. So make post, whoa, make post. In order to make a post, the arguments are the new post. So very, very similar to up here. And actually, what we can do is, if you want to do some troubleshooting, you can return the transaction. So any RPC call that calls a function will return the transaction. So you can, you can throw this in the console log if you want to console it out. It's console log, whatever you want. You can put transaction there, or you could put something a little fancier and say successfully initialized blog ID, blog account, public key for this blog, and then put the wallet public key in there for this blogger, and then return the blog account. And alternatively, you could just throw in the transaction for good measure if you really wanted to. So much like that, let's do the same thing, the transaction, await, program RPC, but instead of initialize now, it's going to be make post. Okay. And we're still going to need to list our accounts. And the accounts from the IDL we know have to be blog account and authority. So blog account again, authority again. Actually, we can probably just reuse this code. Bring it down here because it's the same. The signer again. Signers. Signer would be the wallet pair. See in the make post, the authority has to be a signer, the blog count has to be a signer. No, sorry, blog count does not have to be a signer, but the authority has to be a signer. The authority is the pair, which we've already got listed there. So we're good to go for signers. Now, the other thing that we've done here, though, is we actually have a post that we want to pass into the RPC call, but we haven't done that yet. So we will post with a T, let's pass in a post. And let's assume that this blogger has more than one blog account, and he wants to specify which blog account he wants to blog to. So let's call this, let's call it blog account string. So we know which blog account he's going to be blogging to. let's make the blog account a new anchor public key from that string. All right, so that gives us the blog account public key. Then we need to take that post, and this post is going to be a string, right? So we need to take that string and we actually need to turn that into a buffer. So we'll buffer from, it's Node.js. They went with Node.js buffers in the Anchor library. Unfortunately, I tried to use uint8 arrays in the beginning, but it doesn't work. So you have to go with a buffer. So that will, UTF-8 encode it. And then what we can do is pass the encoded one in to the post, because in our code, actually here, the argument, the new post is in bytes. So it's got to be a byte array. In our program, in part 1 of this video series, make post, you can see it's a vector of bytes. So we need to convert our string into bytes and then pass the bytes into make post so that it will make haste and post away. So once we've done that, our make post is almost complete. Again, we can return the transaction, likely not going to do much with it, but you can do neat things like post, successfully posted this post to, and then throw in the blog account, and we're assuming it's on DevNet. If we wanted to get fancier, we would probably put in a variable there, templated, literal, whatever they're calling it these days in JavaScript, to blank out DevNet, but we're not quite there yet. And so there we have it. We've got make post and initialize in our Anchor client library. Now that we've got initialize make post done, the next thing we're going to want to do is get the latest posts from our blog, right? So get latest post. So for get latest post, we'll pass in the blog account. And the way we can do it with Anchor is by getting the account. So we do await this dot program, because everything is saved to this object that we constructed here, which has the program ID, the config, the connection, the provider, the program, everything is attached to this object. So we'll call it on that program. Anchor has an API to get accounts. If you look into some of the tests in Anchor, you can see that program.account.accountName.fetch, and then the public key is a great way to access account info. So that's exactly what we're going to do. This .program.account. And then you put the account name, in our case is blog account, and then fetch. And then you need to pass in a public key object. So we just have a public key string that's passed in from our JavaScript code. So we need to turn that into a public key from the Web3 library, and that we just use the constructor that's called public key. And we put in this blog account public key, and that will give us a new public key. We put the public key into the fetch on the blog account, and that will give us all the account data for that account in Anchor. All we need to do is return that, but we do need to decode it, because again, it'll be encoded as bytes. So what we need to do up at the beginning here is post somewhere in here a text decoder from UTF-8 to decode it. Go back down to our code and return the decoder /decode account, and then the latest post. Because again, in the accounts field of the IDL, we have all the details on the blog account, and one of them is latest posts. The other one would be authority. If we really wanted to get authority, we could say account.authority, but we really want the latest post because this function is called latest post. So account.latest post will give us the latest post. In fact, why don't we do that anyway? Let's just copy this, put that down there, and let's call it get blog authority. And we'll put that in as a blog ID. And instead of using account public key, we'll just call it a blog ID. And this will get us the authority of, actually, go to the IDL. It's already a public key. See, this was bytes, so we had to decode it. Because this is a public key, we don't actually have to decode this. We just have to turn it into a string. So let's do that. And that'll give us the blog authority. So let's say we wanted to know who the blogger was on a particular blog, which will be important when we get to the front end. We want to display who owns which blog. We can get the blogger. We could have called this get blogger, but get blog authority works as well. So that's neat, but I mean, that's just one post. What if we want to get multiple posts from a blogger? Let's do something called get last posts. And so let's make this called get last posts. We need to be able to know which post we're talking about. So we'll pass in a blog ID. That's blog ID. And we're also, obviously, when you do calls on the Solana blockchain, you can only go to a certain number. Let's limit this to 100. So we're going to get the last 100 posts, but you could pass in, it'll default to 100 posts, but you could pass in a new limit, and you could go up to 500 posts. I believe the Solana API allows you to get up to 1,000 of the last posts. So again, we need to know what account public key we're working with. So we'll convert this from a blog ID, which is a string, to a public key object type. Perfect. So now we need to lean back into the Solana Web3 library here and scroll up to the top and search for something called get signatures for address. Get signatures for address returns the confirmed signatures for transactions involving address. So basically this function will get all the transactions for an address in reverse order. So backwards in time from the provided signature to the most recent block. Okay. So we're going to use this, and that's under connection. So it's connection.get signatures. So let's wrap this in its own function. Let's call it get transaction for address. Make it async. And so we need to use our connection. So this dot connection to access that function. And it is going to return to us the confirmed signature info. It's async, so we'll wait for that to happen. And what do we need to pass into it? An address and options. Okay. So the address, we're going to need an address, which is all addresses are public keys. We'll just use the public key in order to make sure that it is a public key proper, we're going to use the public key constructor again. Seems to be a popular item. And for the option, we can pass in a limit. So let's make the limit default to 1,000. This is that 1,000 that I was talking about. If we go back to it, signatures for address options gives us before, limit, until. So the bookends of the windows in time for this transaction and the limit. So maximum transaction signatures to return between 1 and 1,000, default 1,000. So we're just going to default it to 1,000, which is fine. So once we have this confirmed signature info, what we want to do is get the signatures out of it. So that API returns us, it returns confirmed signatures info out of that. So we've got block time, error, memo, signature slot. All we're really interested in is the signature part because we want the signatures. Because with the signatures, we can get the transaction info. So let's take this information and let's make a map of the elements. Let's call it sig info. And what we want to do is return sig info dot sig. Nah, sure. Okay, that will give us, let's make it, let's call it transaction signatures. Yeah, transaction signatures. So that'll basically just pull out all the signatures from that. And once we have all the signatures, we can use another handy API called get parsed confirmed transactions. So we pass in the signatures to get parsed confirmed transactions. It will give us parsed confirmed transactions. This is going somewhere, I promise. It's a little bit complicated, but yeah. So it'll give us const parsed confirmed transactions. So again, that's a connection function and it's called get parsed. Oh my God. It's called, let's just copy and paste. Right? And we need to pass in our signatures that we just parsed out. Okay, so once we get the transactions, let's return that back to our function. So for any given address, this function is going to go into the address. It's going to look at the public key within the limit. It's going to pull out the signatures. For each signature, it's going to get the transactions and return the transactions. Fantastic. So we just need to go back up to our get latest posts and go, we can just basically call this the same thing. Going to reuse that function in later parts of this application. So we'll leave it in its own function. So wait, this, we call it get transactions for address. And we'll use this as the address we want to get the transactions for. Now we have the transactions. So if you remember from our program, just go back up to it, our program, we actually use this message macro to print every single blog post to the Solana blockchain. So out of these transactions, parsed confirmed transactions, you will see that we have all of these functions. So what we're going to be looking at is meta, because deep inside meta, you have error fee instructions, log messages. Oh, there's our log messages from the message macro. Okay. So what we need is to filter, take these transactions, okay? And we want to filter for each transaction. Whoops, I did that wrong. Filter for the transaction. What are we going to filter on? So we want transaction.meta.log messages, And if the message has, the message starts with program log, then we'll take it. So can we pull up an example of that? Go to memo program. Go to memo program. You'll see that program log. So each of the logs are going to start with this program log and then whatever the message is, program log and then the memo, program log. So we're just going to parse out the log messages from the program logs. Makes sense? So if you go to, say, the program in the Explorer, and you go down to any transaction, if you scroll to the bottom, this program log, see how it says updated program and then there's blah, blah, blah. Well, if it was a memo, it would say log program memo, whatever the memo is. So it's going to skip everything that doesn't start with program log. We're going to filter on log messages for anything that starts with program log. That'll give us, let's call it filtered. Those are the filtered ones, okay? So once we have filtered, then we can map that by each transaction. Oops, I am typos all over the place today. To parse out the data however we want our blog to present it. So we know that there is a timestamp in there. Timestamp can be, let's convert it to a date. It's transaction block time with a capital T. It's in milliseconds. On the transaction, we have a block time, multiply it by 1,000 because it's milliseconds. We want it to be in seconds, and just convert it to a string so it shows up nicely. We will also have program log. So all the program logs will be transaction dot, well, it's the same thing up here, right? Transaction meta log messages. So this is the actual blog post, right? We'll just copy this up here. So include the actual blog post or the log message. And what we will do to make it content wise is take those program logs and we'll map each log. What we want to do is take log and take a substring because we don't want to include program log or that space that starts in front of it. And so we want to remove the length of these characters. What is that, about 1, 2, 3, 4, 5, 6, 7, 8? It's about 13 characters. So we're going to remove the first 13 characters, which represents program log in the space, from the log, which gives us a substring, which gives us our actual content, which is great. So let's make this our post details. That's the filter content. And actually for that, because it's a map, we need to return something. So let's return content Let's return the content and the timestamp. And we're also going to return the signature because that's the way we can uniquely identify each post. So if we want to index our posts, which would become handy to index them, we'll need a unique identifier for that blog post. And we can use the signature as that. So it's already there. We might as well use it. So it's transaction.transaction.signatures. And we'll just take the first signature out of the array. And if you're wondering how I know this, I did a lot of console logging to break all of that out as I was developing this in the beginning. So I've mapped it out well. It's not really super well documented in there, but again, all you really have to do is, console log and then hit the transaction. And then just take a peek in the browser when it runs through this function, and you'll see everything that's available. So I know that it's broken out as tx.transaction.signatures, and then there's an array. We've only got one signer on these functions, so there's only one signature, so it's safe taking the first one. If you had multi-signatures on your transactions, you'd have to figure out which signature you want to pull out of that. Whew, that's a lot to get latest posts. And so all we need to do is return the post details here. Let's return those, and we have our last posts. Filtered, sorted, parsed, filtered, and substringed, and then packaged all up into a neat way that we can use it in our front end. Fantastic. So the other thing we might want to do is for each blogger, like I said in the beginning, each blogger may have multiple blog accounts. So why don't we make a function that also looks up all the blog accounts that are associated with one blogger? So a blogger is a public key account, which is basically your wallet, your phantom public key. And then each of the blog IDs or blog accounts is a key pair underneath that address. And the way Solana works is the program, the blog program, has ownership of that blog account. And since we set the authority to be the blogger public key, only the blogger can change it, even though the program owns it. Let's write another function called get blog accounts so that we can figure out who has which accounts. So let's make another. And so we need to pass in the public key of the blogger. We could have called that blogger ID or blogger public key, but whatever, it's a blogger account. We're going to reuse this function that we just did, get transactions for address and the public key, because that will give us all the transactions for this blogger. Again, this could be, so I'll just put a little note in here, blogger equals public key, right? So get the address for that public key. Again, it's this and it's async, so we have to await it. Continuing on, this get transactions for address is going to give us a same thing as before, parsed transactions, and we need to load all those into blog account. Make this an array, and what we'll do is we'll push all the transactions into array. Grab these transactions, cycle through them. For each transaction, what we're going to do is we're going to look for the instructions. So the instructions are on transactions meta again. And actually, it's not guaranteed that we're going to get a meta on this transaction. So we'll put a conditional parameter on those. And what we do is if we go back to the API, parse confirm transactions, we have this inner instructions, which again is optional. Inner instructions. And on inner instructions, I believe that is, it's an array. Yep, so it's an array. So we'll take the first inner instruction, check that. And then inner instructions We go deeper, we have instructions. Copy that. Inner instructions, also an array, and determine whether it is parsed or not. Parsed, any parsed instruction info. And what this will do, oops, not that, parsed. What that will do is it'll give us the ability to look up the program ID. And I'll explain that in just a second here. Parsed, right? So when we have the instructions, we can say if the instructions, well, first of all, if there's no instructions, or if there's not instruction type, create account. So what we're looking for is instructions where the instruction was create this account, because for get blog accounts, we want to show not just blog accounts that have blogs in them, we want to show empty blogs as well. If we have a list of empty blog accounts, we want to know which ones are empty so we can start using them. So we'll just look for the ones that were created, and also had an instruction where the owner is this program ID. So what this gives us, what this gives us is it checks for all the instructions that were created under this program ID, which are blog accounts. This is the blog program. It only creates blog accounts. So if the blog program owns the account and it was a create account instruction, that means that we created an account and that's the account type. So if we don't get any of that, we're just going to return out of this loop. But if we do, what we're going to do is we're going to push to blog accounts. Actually, what we should do is pluralize this, blog accounts, because it could be more than one. Blog accounts will push that transaction onto it. So again, it's just push transaction meta inner instructions. I could just copy this, parsed. I have to get rid of the questions because we know it exists. Parsed, and then get the info, and what we want is the new account field on the information block of that instruction. And that now we can return. I guess we don't have to really do that out of for each, but anyway, so this will go through each instruction, parse it out, find the one where we created an account under this program ID, and then dig deep down into the instructions and get the account info that was the new account that was created. So every time Solana makes these instructions, as you can see in the Explorer, it really breaks them down into all these addresses. And then it goes by step. So if there was a new account made under this, instead of being authority or buffer account, it would say new account for the create account instruction. So that's what we're doing. We're going to pull that out. And then we'll create an account of those new accounts from the instructions, and those will be all the newly created accounts under this program ID. Okay, and that pretty much wraps up our Anchor client access library. Again, this turned out to be a really long video. I apologize. Didn't realize it would take this long to explain all this in code. But essentially, now that we have this library, all we need to do is instantiate this Anchor client. If we've got Phantom installed, it'll grab the Phantom. You can pass in a key pair and start working with that and post, initialize and post everything through Anchor, through the Anchor API. You can get the latest posts and all the transactions for the account. So I'm going to end this video here. That's the Anchor client library, and you can access all of that. And hopefully this helps you guys hack on Solana a little bit more. So until next time, we will see you later.